Welcome to the Battery Testing Mentor podcast, a podcast about battery testing, battery validation, battery safety, battery regulation. Today, we are continuing here with the interview with Thomas Günther and Paul Büschel from Limatica. And last time we talked already about the typical approach of how do you validate if a cell was produced right or if there is some problem in the cell, and how Limatica is approaching this, an innovative testing methodology. Today we are diving more into the technical aspects, and I would directly continue with the interview. But first, if you have any questions, any recommendations, anything you want to share, just feel free to reach out to me via the typical channels of YouTube, LinkedIn, or via the email. If you just reply on the email that I send out with every episode, you can also directly reach me. And also, if you want to get in contact with Thomas or Paul, just send me a message and I will forward your request. Then have fun with the interview. So basically it sounds like, or what comes into my mind is then often like this impedance spectroscopy that sounds a little bit similar. But as you said, you are kind of just using the stethoscope. You're not actively kind of triggering the cell, right?
Exactly.
But is there some parallel, or would you say this impedance spectroscopy is something completely different and can't be used at all?
First, we have to look at the magnitudes of the effects that we are looking for. So the voltage drop of a cell is caused by some sort of self-discharging process or in the defects, and the current that is the effective self-discharging current is quite low in the range of microamperes. And if I want to detect it with some sort of active method, I would need to have an active current that is much lower. So I want to, with an active method, I'm actually overpowering the effects I want to see. So this is one reason why impedance spectroscopy is not really working with that. The second reason is the way impedance spectroscopy evaluates the data. So with impedance spectroscopy, you're looking at distinct frequencies for where you calculate the impedance. And you do this by Fourier transform, so by a correlation method. And what this does is it neglects all the other information that is there. So you're just looking at one frequency. And the intrinsic activity of a cell is usually some sort of random process. So it's the information spreads out in the noise. And this is actually what you want to avoid with impedance spectroscopy. You're frequency selective, and you want to blank out the noise actually that you consider noise, but actually is containing information on the activity of the cells. So this is why we think that impedance spectroscopy is not suitable for this job, for this very specific application in cell manufacturing.
Yeah. Okay. Interesting, because I mean, this topic of noise is something that also I encountered a couple of times in my experience in the test lab, where you basically don't want to have the noise, right? Like you don't want to have this ripple kind of on the voltage signal. And I mean, very often this also comes from external sources like electromagnetic influences. Now, basically, you need to distinguish basically between kind of this noise that really carries information and something that is inputted from the outside, especially like I imagine when you are in such a factory hall where the cells are produced, it's not necessarily the nicest environment in terms of electromagnetic noise, right?
You are correct. So you need to deal with different types of noise. Mainly they are noises coming from switchgear and from switching equipment. So these are distinct spike-like noise signal parts that you can see in the time signal. We handle this in the time domain directly. So we blank them out essentially. And the other type of noise sources like mains interference and harmonics and so on, we can distinguish in the temporal structure. So after transforming the noise data, we can also see that there's mains noise coupled in from outside. And we can also blank it because we can distinguish it from the information of the cell.
Okay. Yeah. So basically, it's not only just measurement, but it's also a lot of data analysis and data kind of working on data.
Yes, so the whole process or whole measurement chain contains signal analysis, then signal transformations, data handling, and a large part is also machine learning in our case. So learning how different batteries behave with their noise and learning to interpret this noise.
Yeah, yeah. So do you, or can you then just measure any cell, or do you need to also kind of train your system, like kind of almost like big data, where you say, okay, you need to do thousands of cells first, and then you can give a result?
Let's say currently a training phase is always prepended. So let's say the answer would have two sections. In terms of measurement, any battery shows these intrinsic activities. So the measurement method we can apply to any battery, or let's say to any electrical system. Batteries, we've already talked with manufacturers of fuel cells and so on. So anything you can connect does show these effects. And so we have, let's say, a tool we can apply to lithium-ion batteries of whatever cell chemistry, particular recipe, lead acid, whatever. So we can apply this to anywhere. But in terms of signal processing, so currently it's a data-driven approach. So when we have a new customer or a new product, we investigate. We have something we call an onboarding phase. We have some test campaigns we run first to collect information on the batteries to see, to find good cells, distinguish them from bad cells, and correlate it with the patterns we generate. And from then, the next step is just looking on the data and sort them out. The last part of the answer would be more related to our mission. Yeah. So where do we want the method to be in the near future? Possible, hopefully in the near future, would potentially to be in the situation to be able to skip the first step. But therefore, let's say there's quite some development to do at our side to have it in a more generic way that we can apply to any battery at any time and answer these questions directly. So currently, we need to measure on the battery, learn the method, let the method learn for this specific type, and then we can apply this again for the battery afterwards.
Yeah. I mean, I guess if you have it at a point where it just works with the first cell, you basically touch something like the holy grail of this.
This would be really cool, yeah.
Battery analytics. Yeah, very good. I'm really looking forward to this moment, because then you can basically really do any test and do this quick measurement basically, and then you know what was the impact. I mean, very simply speaking, but yeah.
Hopefully. Paul, you're muted. Yeah.
You are sketching the bright future, let's call it, yeah. Where you can do a magic measurement, let's call it, and this measurement tells you what the problem in your process was. So we're not there yet. We are really working hard to get near this goal,
Yeah.
but it's tough.
Mm.
Yes.
Yeah. Okay. I'm looking forward to this point in time. Hopefully next year, then I come and visit you with some cells.
Would be awesome.
No,
Yes.
but
So,
I mean, I really have my fingers crossed for this. So basically, you said before that you are already in some production lines and kind of try it out and validate that your system works as kind of the typical old approach. So does this mean you are now already to really go into like big scale productions? Like, I mean, these typical gigafactories of PowerCo, and I mean, there are a lot of other names that don't exist anymore, but basically these big cell factories.
we are starting with measurements now. So we are not there yet. We are aiming going into bigger lines, bigger production lines by the third and fourth quarter this year. So this would be the aim. But right now we are starting with measurements with manufacturers.
Okay. Well, I mean, very exciting. Probably it's really now comes to prove that it really works also with this time pressure of the manufacturing processes, right?
It would help manufacturers to, let's call it, supercharge their process. So getting more information earlier in the production process to have more time to react. This is the biggest pain point with the manufacturers right now. They realize after many days that their cells have a problem and they need to fix it. But the process that caused this problem worked badly a few days ago. So in the meantime, many cells were produced, and they are not really sure what the problem is. So this is essentially critical when you ramp up a plant or when you switch the generation of the cell, for instance.
So in general, this is, let's say, just an addition. So what we see becomes is quite critical is the dead time in the process feedback. So when you have days before you can react, it's really critical for controlling a process, any type of process. So this all for sure as well applies for the cell production process. And in general, you have two phases where this becomes critical during cell production, ramp up of a production line in general, and from feedback from our customers, iteration on the product generations become shorter, so the ramp up problem occurs more frequently, and so for a cell manufacturer, this becomes a big issue when it's related to big cost. When I need to do the product update, but as well, it will take a very long time until the cell production line runs properly again. And so the key is, let's say, information to provide information on the cell production process with a very short dead time. And this is what we aim for right now, because this is something we can, let's say, deliver more or less today, because the measurement process is non-invasive. You can just add it to your production process without some, let's say, affecting the cells during the cell production. So it's a passive method. You can apply it to some cells in parallel without changing your production process. And it's a tool you can have in parallel to get a better understanding on what you're actually doing compared to now.
Yeah. Okay. I mean, it was once again like a very good summary of kind of the key advantages that you propose, right? Like with your tool. Are there any other like messages, wishes things you want to tell the listeners? There's something you want to share?
So we would like to see the battery community and the cell community in Europe to grow a little bit more, have less setbacks as we've seen in the last few months, and gain so that European and Western manufacturers gain more confidence in what they are doing, and finally produce really good cells with improved production technology. So better cells, more cost effective, with higher quality.
I totally agree, Paul. So this is one of the main points. To get there, cell manufacturers actually have to get their hands dirty. They need to know their product, they need to understand their product. And the question is, what are the right tools to get there? From our point of view, what we provide is something which will help to get this. And the other, let's say, wish, let's say, call it like that maybe, is some of the manufacturers are already quite open to do things, but some of them are, let's say, still quite preserved. And they need to want to have evidence on things maybe in this particular setup are hardly able to be provided, because it's a new technology, so there cannot be a mass scale production, a proof on mass scale production. Yeah. So the typical chicken egg problem, I think almost every startup has. So some manufacturers understand this and are able to let's say walk the way with us, and others, let's say, maybe need a little push. Yeah. And this would help a lot. Yeah.
Okay. The question is only who pushes or
Yes.
who has the guts to push. Yeah, I mean, this is a discussion. I mean, we could do a separate podcast about the state of the battery industry in Europe. I guess there is a lot of things that don't run as we would all wish for, I guess. Yeah, but thank you very much for coming here, for sharing your insights and presenting your technology here. I wish you really like a lot of good luck, and I'm really looking forward to this point in time when we really can meet again, and then this measurement system just works on any cell. That would be really impressive.
We're working on that. Thank you very much, Johannes.
Yeah. Thank you.
I keep my fingers crossed. Okay, then thank you very much.
Thank you.
Thanks a lot for having us here. Bye.
Bye.